Okay, ready? We're going to take notes. Are you ready?
No!
Okay, and those of you watching this, I'm recording it in a class, so when you hear their questions, you know it's them. Okay.
Other class.
All right. Kingsley, what was our learning target today?
I can describe and give examples of Newton's laws of motion.
I can describe and give examples of Newton's laws of motion. Thank you. So, here we go, guys. We're going to take some notes. I should see notebooks open to pages 71, please. All right, title of our notes, Newton's Laws of Motion. Okay, so today we're going to write down notes on Newton's laws of motion. There are 3. So Isaac Newton described how objects move. Ezra. That's exactly true. That is the first law. So, and Isaac Newton didn't make things crazy and give them crazy names. We've got the first law.
What's that little thing next to it, sir?
What's that little thing next to what say? Newton's laws. First?
Oh, that's his first.
First. First law. Okay, then Newton's first law says that an object in motion will stay in motion. And an object at rest will stay at rest. Until acted on by an outside force. Okay, and we have seen this over and over and over, even in our labs. Objects aren't going to start moving or change their motion unless you add another force. Right?
Kind of like a. Wait, but I am confused with like an object in motion will stay in motion.
Good. So if I bowl a bowling ball, it's going to keep rolling until it hits something else.
Oh, I see.
Does that make sense? And then that would be an outside force. So friction is an outside force that causes motion to stop. But if we had a frictionless plane, like if you like ice sports, space, air hockey table, where there's less friction, there's more motion. Things don't want to stop moving. Okay? This is also known as the law of inertia. Also known as, AKA, the law of inertia. And inertia is simply that objects want to keep doing what they are doing. So it is Newton's first law of motion. You guys are about a year away from getting your permits, from driving. Yeah.
Yeah, a lot of people are almost 6 or 14.
I'm 14. Yo, I feel like I shouldn't be this old.
So when you drive a car, when you ride in a car, Newton's first law of motion is why you need to wear a seatbelt when you are in a car. Okay, so let's envision ourselves in our car, driving down I-25. The speed limit's 75 miles per hour.
And somebody in front of me is going too slow, so you gotta be
Okay, so if you are traveling at 75 miles per hour, your car is going 75 miles per hour, your body is also going
75 miles per hour.
75 miles per hour. If your car were to suddenly hit something and stop very suddenly, your body wants to keep moving forward at 75 miles per hour. So you would be thrown through the windshield if you are not wearing a seatbelt. Seatbelts are super important because of Newton's first law of motion. I'm going to draw a little guy with a seatbelt on. Where's the seatbelt? Wear seatbelts. Okay, this is also why figure skating, you're able to glide, right? Because there's not a lot of friction. Speed skaters.
Oh, that's a nice ice cream.
Hey, thanks. Okay, so first law of motion, objects want to keep doing what they are doing.
Oh, I need a creepy ice cream.
A creepy ice skate? Okay. All right. So, guess what his next law is called? It is. It is called the second law. And Newton's second law says that the acceleration of an object, how quickly an object speeds up or slows down, depends on the mass of the object and the amount of force applied.
Is that what we write down?
Yeah. So here we go. The acceleration of an object depends on the mass of the object and the amount of force applied. So we have seen Newton's second law over and over and over. We've done a bunch of different labs where we saw that if we exert more force on two objects that have the same mass, the one where we push harder, it's going to accelerate more quickly. It's going to change velocity more. Yeah?
Yeah.
Or if we put the same amount of force on two objects, like the ping pong ball and the golf ball, the ping pong ball will accelerate more quickly than the golf ball because it has less mass. Okay, so we've seen this over and over in lots of the labs that we have done so far. So this is simply that force is equal to the mass of the object times the acceleration, how quickly it is changing velocity. Force equals mass times acceleration. This is why it's easier to throw a tennis ball than a bowling ball. Less mass. Huh?
What?
Okay. And then his final law He got really wild. The next one's going to be called the.
Third law.
It is the third law.
He just comes up with the most creative names
Right?
ever.
This guy's almost.
All right, his third law says that for every action, there is an equal and opposite reaction. This is what we saw on Friday. For every action, there's an equal and an opposite reaction. When SpaceX or NASA launches a rocket, put the Barbie skateboard away. Okay, what way do the jets exert a force? Downwards, right? Right, we've got the jets. They make that noise. They push down and launch the rocket which way? Up. When you guys walk, every step you take, what direction are you pushing on the earth?
Down.
Kind of backwards, right? Think about it. Everybody stand up and take a step. Which way do your toes push?
Backwards.
Backwards. And which way do you go?
Forward.
Forwards. Or on a scooter. If you're on a little scooter. Or skateboard. You push. And you go.
Forward.
Good. Here's a really good skateboard. You push backwards to go forwards. Okay, so those are Newton's 3 laws of motion. I have got a video for you that we will watch on the next slide on how all 3 of these laws are applied to riding a bicycle. Okay?